Morning all. Myself Dr. Avinash, Assistant Professor, Department of Chemistry, ATB of College of Engineering, myself. So today let us observe the experiment on applied chemistry lab for all streams of it you. So that is the colorimetric determination of copper. So before moving on to the experimental part, first we must know what is colorimetry. Colorimetry is a quantitative analytical instrument which is used to measure the transmittance and absorbance of the light passing through a colored liquid sample. So this colorimetry is based on two fundamental laws. One is called as Beer's law, the other one is called as Lambert's law. Beer's law states that when a monochromatic light is passed through a colored solution and when the path length of the media is kept constant, the absorption of light by the solution is directly proportional to the concentration of the solution. So when you look at these three cuvettes, so you can observe that there is a variation in the color intensity. That means there is variation in the concentration of the solution, and I have kept the path length constant. In this condition, when I pass the monochromatic light, the one which is having low concentration tends to give very less absorbance and with more transmittance. In a similar way, the one which is having higher concentration tends to provide more absorbance with less transmittance. Hence, according to Beer's law, the absorbance is directly proportional to concentration when the path length is kept constant. Coming to the Lambert's law, it states that when a monochromatic light passes through a colored solution of constant concentration, the absorption of light by the solution is directly proportional to the path length of the solution. Again, you can look at the thing where I have maintained the concentration same, that is the color is same, whereas the path length has been varied. When you pass a monochromatic light through this solution, the one which is having the lower path length tends to provide less absorbance with more transmittance, whereas the one which is having the higher path length shows more absorbance with less transmittance. Hence, according to Lambert's law, absorbance is directly proportional to the path length. So combining with these together, we call it as Beer's-Lambert's law, which states that when a monochromatic light is passed through a colored solution, the absorbance is directly proportional to the concentration of the solution when the path length is kept constant. That means A is equal to epsilon Ct. A is the absorbance, C is the molar absorption constant, epsilon is the molar absorption constant, C is the concentration, T is the path length. The absorbance of the colored solution is measured at a particular wavelength, lambda max, what we call it as the monochromatic light. So coming to the instrumentation, it consists of the following parts. It is also called as photoelectric colorimeter, also called as spectrophotometer. Mainly it consists of a tungsten lamp which can emit the radiations of wavelength in the visible region, that is 400 to 750 nanometer. And a monochromator, it might be a filter or a grating. So it is going to split the light into different wavelength. And a sample cell, which is the path length which is kept constant. And a photocell detector which reads the remaining light, means the transmitted light. And finally a digital display which provides the absorbance or transmittance in some terms of digital parameter. So the working of the colorimeter is as it is. So this spectrophotometer, so it consists of a tungsten filament. So this tungsten filament is the source which provides the light. This light passes through a slit and falls on the grating or a prism. This grating or prism splits the light into different wavelengths. And using another slit, we are going to take up a monochromatic light and will be allowed to pass through a sample holder where the sample has been placed. The remaining light which is transmitted falls on the sensor, and the amount of light absorbed will be noted down. So coming to the determination, the following chemicals are required. It is the copper sulfate and ammonium hydroxide. Initially we have to prepare a standard solution around 0.4 molar of copper sulfate in 100 ml of distilled water. To this, now what we have to do, we have to take around 6 we have to take 6 standard flasks. So to these standard flasks, label it as 5, 10, 15, 20, 25 and a test solution and a blank solution. So now add around add different volume of copper sulfate, and to that you add 5 ml of ammonia solution. Then measure the absorption spectrum of this solution at 620 nanometer. So once you are going to measure all the absorbance, draw a calibration graph between absorbance and concentration and find the concentration of the unknown solution by repeating it in the same way. Let us see the experiment how we have performed it. So here these are the 4 standard flasks what we are having. Label it as 5, 10, 15, 20. One standard flask will be maintained for blank and the other will be maintained for the test sample. So this is the 4 colorimeter what we are having. It is the helico based, and 2 burettes to fill the solutions to the standard flask. Later on we will be having ammonium hydroxide ready and copper sulfate which has already been prepared. Now transfer the copper sulfate solution into the make it to 0. Then to the another burette fill the ammonium hydroxide what has been prepared. So after filling ammonium hydroxide, replace it to the burette stand. Now fill the standard flask with various volume of copper sulfate like 5, 10, 15 and 20. So here we are going to go in the reverse order. First 20 ml will be filled, later on 10, later on 15, 10, 5 will be filled. In the similar way, fill the remaining standard flasks. So you can see the change in the volume 5, 10, 15 and 20 cm cube of copper sulfate filled. Now to this each standard flask add 5 cm cube of ammonium hydroxide solution. This ammonia combines with copper sulfate, reacts with copper sulfate for forming cuperammonium sulfate, a dark blue colored complex. So in the same way, fill all the remaining 4 with the 5 cm cube of ammonia. So you can clearly observe the change in the color, means you can see light to dark color. Now make up the standard flask with distilled water. In the same way, make up all the standard flasks and you can see the change in the color intensity. The one which was having lower volume of copper showed a small thing. Now adjust the filter to 620 nanometer because cuperammonium sulfate complex, it absorbs maximum at 620 nanometer. And now fill the cuvette with distilled water. Once fill it with distilled water and set the instrument to 0. And set the instrument to 0 by placing it in the sample holder. Once set to 0 by distilled water, again fill the cuvette with the blank solution. Blank means the one which does not contain copper sulfate. Remaining only ammonia and water. And now replace it back in the sample holder and again ensure the 0 absorbance. Ensure the 0 absorbance. So it's already 0. If not, set the instrument to 0. Now place it back in the cuvette holder and then fill the other cuvette with the various samples. Place the solution, wipe the cuvette thoroughly and place the solution in the sample holder. record the absorbance, what you are going to measure, then replace the solution with the second solution. Before going, set the instrument to 0 by using blank solution and repeat the same for the remaining 4. Note down the reading of all the 4 flasks. And now, so this is the test solution whose copper concentration unknown to us. To this again add 5 cm cube of ammonia solution and make it up to the mark, and note down the reading, colorimetric reading, which is the absorbance provided by this solution. So record the absorbance now. Record the absorbance provided by the test solution. Note it down. Note down the reading. So now, tabulate whatever is done. In one column, note down the volume of potassium, copper sulfate added, and in the other column, add the amount of ammonia added, and finally record the absorbance what you have got. Now plot a graph of concentration in the x-axis and the absorbance in the y-axis. You are going to get a linear graph which passes through the origin. Now see the absorbance provided by the test solution, and at the y-axis mark down the absorbance and extrapolate the graph towards the x-axis. So the point where it meets is the volume of copper which was present in the test solution. So this was the volume present in the test solution. We know that 1000 cm cube of stock solution contains 8 grams of copper sulfate, and again 214 grams of something copper sulfate contains 63 grams of copper. In such case, what if 8 grams of copper sulfate contains how much amount of copper has to be recorded? Finally, it should be calculated to 1 cm cube of copper sulfate, where how much it contains, and multiply it by the volume of copper obtained. That gives the amount of copper in the solution. So thank you for watching this video.